Hello and welcome to this video. So in this video, I'll be talking about ACL principles and configuration. Now the name ACLs is pretty much confusing. Access control lists makes it feel like ACLs are used to block or permit traffic. And whereas that is partially true, that is not entirely the job of ACLs. In fact, it isn't the job of ACLs at all. Well, we shall see the permit and block kinds of words, but ACL's main job is really to identify traffic. Their job is to identify that, hey, this is a packet in the stream of traffic you told me to look out for. And then, depending on what you're using the ACL for, the ACL, rather the application or the tool to which you've applied ACL is going to take effect as required, as we are going to see. So let's get on right with it. Rapid network development brings challenges to network security and quality of service on the networks. So ACLs, access control lists, are very related to network security and also to quality of service of our network. So the job of ACLs is to identify packet flows. And by accurately doing that job on a typical network and working with other technologies onto which you apply the ACLs, ACLs can control network access behaviors effectively and prevent network attacks and also improve network bandwidth utilization, thereby ensuring the network environment security and quality of service reliability. So we will be looking at an ACL used together with a particular technology, like network address translation, like telnet, like packet filters or traffic filters, and several other technologies. This chapter describes the basic principles, the functions, the types and characteristics, basic compositions of ACLs, the ACL rule matching order, the usage of wildcards, and typical basic ACL configuration. Now, I must warn you in advance, the implementation of these ACLs varies with vendors. Different vendors have their own implementation of ACLs. So Huawei implements ACLs in a certain way. And by the way, what we are going to be discussing as implementation in this recording, in this video, is Huawei's implementation. We are describing ACL technology as implemented on Huawei devices. Now, you also remember that a local area network is a computer network that connects computers in a limited area, residential area, school, a lab, a college campus, an office building, a typical area of that kind of sort. So we'll be looking at applications of ACLs and use of ACLs according to Huawei implementation in a typical campus network. So upon completion of this chapter, you'll be able to describe the basic principles and functions of ACLs. You'll be able to understand the types and the different characteristics of the different types of ACLs. You'll describe the basic composition of ACLs and the rule ID matching order. You'll understand how to use wildcards in ACLs and what exactly wildcards are, and you'll be able to complete basic configurations of ACLs. I'm going to make the ACL coverage in 3 different part videos. The first one is going to be the ACL overview, and this is it. The second one will talk about the basic concepts and working mechanism of ACLs. And in the third one, I will show you typical lab configurations of applications and usage of ACLs. So let's start with the overview. First of all, let me show you a simple typical topology of a typical campus. So right here we have a research and development department on the network 192.168.2.0/24, meaning there are several users on that subnetwork. We also have VLAN 20 on the network 192.168.3.0/24, typical users in the president's office at that network. We have the financial department server. This is a server for the financial department, particularly residing at the 192.168.4 network, and particularly it is .4 host/24. Now, this is the financial department server. It is a server that is accessed by the financial department. Maybe there is some financial data on it, maybe, whatever the kind of data on this financial department server, it is a server for the financial department. Now, typically, if we release if you connect a network such as this is our enterprise network, to the internet to enjoy internet services, there's going to be a risk of viruses that come from the internet to access our network. We don't want that traffic to be permitted into our network. Secondly, there are high chances that different people in different departments will attempt to access the server. Now, if we let everyone access servers of an enterprise, they are normally going to be used. The resources of key servers of the enterprise will be, first of all, obtained without permission. Confidential information of the enterprise might leak, which will cause a potential security risk to the enterprise. More so, there is going to be overload. Network bandwidth is going to be occupied by services randomly. People from the research and development are logging in. People from the president's office are logging in. People from the internet are logging in. We don't want our bandwidth to be misused. These are main problems that lead to the need of some kind of access control. So instead of reserving our bandwidth for delay-sensitive services such as voice and video, we cannot guarantee that anymore, and thus our user experience is going to drop considerably. Now, all these issues affect two main things in our network. They affect the quality of service, and they also affect security. So these two things, quality of service and security, need to be improved urgently on the network. And so we need some important tool that can filter traffic. For example, we need some tool that might reside on this router because it's at the center of this network. And then it's able to identify that, oh, this traffic is from the internet and it should not be coming in. So this tool will probably block that traffic from around that point, or block that traffic from entering that site. We also need some kind of tool to say, oh, you guys from the research and development department, we don't want them to access this financial server because they are from research and development. Why are they accessing the financial server? So while this router is receiving traffic from there and from there, we need some guy right here in this router to say, oh, I see this packet is from this network. What do we do about this packet? We need some guy to be able to identify, to check in our packet headers, in the IP header, and say, this is a packet from 192.168.2.0 network, particularly from the 2.6. What do we do? And then we'll deploy some service at some point, either there, to stop this traffic from continuing that side, or right here to stop this traffic from hitting this point. Basically, we need someone to identify the traffic, to say, no, this one is from 19168.3.0, they're allowed to go up there. And this one is 19168.2.0, they're not allowed to go out there. And maybe we don't want people in research and development we don't want people from the president's office to directly access internet. We can still deploy some guy here to identify this traffic and another guy to stop the traffic from proceeding to the internet. Now, an important question becomes, do we really have any tool available filtering traffic? Do we have any tool we can deploy to say, this traffic is from this network, or this traffic is going to this service, to HTTP, it's FTP traffic, or this traffic is moving at this time. We need somewhere to say traffic moving at this time should not be permitted. We need a way to filter traffic, and the good news is we have such a tool, and that tool is exactly what we call the ACL. So let me introduce the ACL on a general scale right here. ACLs accurately identify and control packets on the network in order to manage network access behaviors, to prevent network attacks, to improve bandwidth utilization, and in that way, ACLs ensure the security of our network. and also the quality of service of our network. But what exactly is an ACL? Well, that's a very simple question. As you can see right here, it's just a set of sequential rules. So we have rules. Rule number 1, don't do this. Rule number 2, do this. Rule number 3, do this. Rule number 4, don't do this. Rule number 5. It's just a sequential list. It's just a set of sequential rules, and these rules are composed of permit and deny statements. I'll explain those in a moment. Now, the ACL is going to match and distinguish packets. But the question is, how is it even capable of doing that? Well, the ACL classifies packets by matching fields in the packets. We know that when the packet is moving, it had some data that came from layer 5, the application layer, and that data got encapsulated at layer 4 with the layer 4 header, which is a typically TCP header or UDP header. And as it came down to layer 3, it also got another header, in our case, the IP header. So ACLs can look into these headers. ACLs can look into, for example, the source and destination IP address, the source and destination layer 4 port numbers, the protocol types in IP datagrams, and it can use those particular fields inside those headers to match traffic, to say, oh, this is the traffic going to this port that you talked about. So what do I do with this traffic? Or this is the traffic that is coming from this IP address that you mentioned. Or this is the traffic that is heading to the HTTP server. What do we do? This is the traffic from the HTTP server. What do we do? This is FTP traffic. What do we do? They can use elements inside these headers to identify the traffic. Now, when the ACL identifies traffic, we are going to apply that ACL to a certain ACL application, and that ACL application will now determine what to do with the traffic. This is why I say the ACLs will not block your traffic or permit your traffic, but they're simply going to identify it. And once they identify the traffic, the tool to which you apply the ACL is going to handle that traffic depending on whether it's a permitted traffic or denied traffic as per the ACL statement. So we can use the result to match IP traffic, for example. Actually, this is what ACLs do. They match IP traffic. Now, when they match IP traffic, we can invoke the ACL in a traffic filter. That's where we get to this router right at this interface and say, traffic filter, this inbound, when traffic match that this ACL matched comes in, do handle it like this. Or traffic filter, this outbound. We are going to look at that in a moment. In fact, in this chapter, we are going to use traffic filtering as an example to describe ACLs. But do not be blinded. Do not forget that these ACLs, the same exact ACLs, can also be invoked in network address translation, so that the ACLs that match certain rules, the traffic that matches certain rules is the one whose network addresses will be translated, and the one that doesn't will not have its IP addresses translated. We shall look at that in a different video. They can also be invoked in a routing policy. They can be invoked in a firewall policy. They can be invoked in quality of service and several other applications. So this is the overview of ACLs. In the next video, I'll take us through the basic concepts and the working mechanism of ACLs. I hope this has been informative for you, and thank you for viewing.